In this video, we are going to learn how to manipulate formulas. We're going to be doing the same thing that we did in previous lessons, except instead of having numbers, we're just going to solely be focused on formulas. That is what it means by manipulating a formula. We're rearranging a formula so we can get a variable isolated. So let's look at this here. We have volts is equal to current times resistance. Let's say I want to rearrange this formula for my resistance. That is what we mean by manipulating. The only difference is before is we had numbers all over the place and some variables. This time we're just going to be looking at variables. Every time we do questions like these, you're going to be having a legend that tells you what each variable represents. And then eventually we'll get into word problems and solving and stuff like that. But first I want to work on manipulating variables. So let's look at this here. For this first question, we are currently solving for my volts. But it wants us to rearrange the question to solve for my resistance. So now we want to look at this guy. So let's take a look at this here. I'm going to first go our old way of looking at this. Volts is equal to current times resistance. So we're trying to solve for resistance. What is the first thing we're doing to resistance? Now we're always going to still follow BEDMAS like always before. So first thing we are doing is brackets. There's no brackets, but there's no exponents, but there is multiplication. So we are multiplying by my current. So I get IR, current times resistance, and that's it. Then it is equal, that is equal to volts. So what is the opposite of multiplying by current? We're going to divide by current, which gives me my volts divided by my current. So in other words, we know that resistance is equal to volts over current. Okay. Another way we could do that is, remember, we're just looking at the opposite operation and performing the opposite operations and in reverse order. So now it wants us to solve for I. So we know volts is equal to current times resistance, and it wants us to solve for my current now. So I'm looking at current. So what is the first thing I'm doing to current? I'm multiplying it by resistance. Okay, now we have built up my right side of the equation, and we know that's equal to the left side of the equation. So now let's deconstruct it and construct the left. So I'm going to divide by resistance. So volts divided by resistance. So now I end up getting my current is equal to volts divided by resistance. That's it. So now we're going to look at a more complicated one. Now, this one has both numbers and variables, and we also have an addition sign in there. But it's not really that bad or different from anything we've been doing before, because variables are essentially just numbers. They're just a representation for numbers. They make things actually in some ways easier. You don't have to write as much. Because if here we have my distance was 852, velocity was maybe 156.3, well, that's a lot to write out. If we just write out these, it's a lot quicker. So it's kind of like a lazy way, an easier way of organizing stuff. Now, this one here we have distance is equal to my final velocity plus my initial velocity, all divided by 2, multiplied by my time. And in this case, it wants us to solve for my final velocity. So we're going to isolate for final velocity here. So let's take a look here. We're going to look at final velocity. Now, what is the first thing I'm doing to it? So a key thing here is we might say this can be rewritten as final velocity plus initial velocity. And then we could say divided by 2 and then multiplied by t. So this 2, since the fraction line here goes completely underneath all of the numerator, that means both of these are divided by 2, which means we have to do that operation first. That's a part where we must always pay close attention to make sure we're doing this right. So my first operation is to the final velocity, we add my initial velocity. So I end up getting final velocity plus initial velocity.
Then I look at this, I divide by 2. So I get final velocity plus initial velocity, and then I'm going to divide by 2. And then my last step here is we multiply by t, or time. So I get final velocity plus initial velocity divided by 2, and that's all multiplied by, time. Now this is equal to distance. We're done the one side and we're going there. So we want to do the exact opposite first. So I'm going to divide by time. Next, I must, instead of divide by 2, I'm going to multiply by 2, the exact opposite. And then last, instead of adding initial velocity, I am going to subtract my initial velocity. So I get and there is my answer. So we end up going like this. We know that my final velocity is equal to 2 times distance divided by time minus my initial velocity. And that's it.
Okay, so let's look at another formula here. So here we have my final velocity squared is equal to my initial velocity squared plus 2 times my acceleration multiplied by my distance. Well, we want to solve for VF. Well, it's mostly already there. VF is already isolated. So we have VF squared. If I was to do it this way, we'd have VF, and then what are we doing to it? We are just squaring it, so we get VF squared, and that's equal to all of this here, V initial velocity squared plus 2 times acceleration times distance. And what is the opposite of squaring? That is to square root. So I'm going to end up getting the square root of all of initial velocity squared plus 2 times acceleration times distance. So if I look at this here, we have this is equal to square root of initial velocity squared plus 2AD. Or what we could have done is we already knew it was already isolated. All we did was square root this side, square root this side. And it's very similar to your Pythagorean theorem. So let's look at my next one. Now we want to rearrange for my initial velocity. So I'm going to rewrite out my whole formula. Okay, and we want to solve for my initial velocity. So we're going to start here with initial velocity. Okay, and what are we doing to my initial velocity? Well, first thing we are doing is we must still follow BEDMAS. So brackets, no brackets, first thing we're doing is squaring. So we are squaring it. So I get, okay, next thing we are doing is we are adding 2AD. And this is equal to VF squared. So now, first thing I must do is, we look at this, we're going to subtract 2AD. Okay. Then, instead of squaring, we must square root, which is going to give me so we know VI, my initial velocity, is equal to the square root of final velocity squared minus 2 times acceleration times distance. Alright, so now this one here wants us to solve for A.
So I'm going to write out my equation again, and then we're going to solve for a. So we have, oopsie, and we're trying to isolate for a. So I'm going to write out my a here. And remember, we're still following BEDMAS. So we're looking at a. Are there any brackets? Nope. Not around a. Are there any exponents? Nope. Are there any division? Nope. Is there multiplication? Yes. There is a multiplying by 2 and d. Which gives us 2. Now, let's continue this here. Next, is there addition or subtraction? Yes, there's an addition. We are adding this part here. So now we're going to go plus vi squared, my initial velocity squared, which will end up giving me and we know this is equal to my final velocity squared. Okay, so what's the opposite? We want to minus my initial velocity. So we have final velocity squared minus my initial velocity squared. Then, instead of timesing by 2d, we're going to divide by 2d. So I get and there we go. So we know my a is my acceleration is equal to my final velocity squared minus my initial velocity squared divided by 2d. That's my answer.
So now I want you guys to try and solve for d by yourself. I'm going to ask you in class tomorrow on how you solved for d and what you got for an answer and how you did it. I'm going to be checking. All right, see you later.